My name is Marwan, and I am pleased to present this video, which demonstrates our graduation project that has been sponsored by Siemens. V2X is a communication technology that enables vehicles to communicate with various elements in their environment. It allows vehicles to exchange information with other vehicles, infrastructure, pedestrians, and networks. Our main focus will be on V2G, V2V, and V2N. Our project consists of three main parts. The first part involves implementing smart charging communication between an electric vehicle and the supply equipment, following the ISO 15118 standard. Additionally, we will be sniffing and analyzing this communication traffic using a V2G sniffer and Wireshark. The second part focuses on the communication between the supply equipment and the charging point management system, following the OCPP standard. The third part of our project addresses the broken-down vehicle use case. In this part, we aim to develop a system that allows a broken-down vehicle to inform nearby cars about its situation, enabling them to take appropriate actions. The first two parts of the project focus on smart charging using V2G technology, while the third part focuses on enhancing efficiency using V2V technology. In our project, we have 4 demos. 3 of them are dedicated to showcasing the implementation and functionality of smart charging using V2G technology, and the 4th demo focuses on the broken-down vehicle use case. There are several companies that are interested in our project, such as Vector, Audi, Tesla, and Electrobit. In our project, we have successfully implemented the ISO 15118 standard, which serves as the communication protocol for electric vehicles and supply equipment. This standard is designed to enable smart charging functionalities and provides a set of requirements for each layer of the OSI model, ranging from the application layer down to the physical layer. The innovative aspect of our project is the implementation of a V2G stack that adheres to the AUTOSAR standard. This implementation is achieved through a combination of existing AUTOSAR modules and modules designed to be compatible with the AUTOSAR framework. During our system architecture demonstration, we will highlight the key components involved. Our architecture primarily consists of 3 main components: the electric vehicle, the supply equipment, and the V2G sniffer. First, the electric vehicle component. Within the EV, we have the electric vehicle communication controller equipped with the AUTOSAR V2G stack. This controller enables smart charging from the EV side. Additionally, the battery management system of the vehicle provides information about the battery, including voltage, current, and capacity. The Nucleo board acts as an intermediary, receiving battery information from the BMS through CAN and transmitting it to the EVCC. Furthermore, the Nucleo board also communicates this data to the dashboard Raspberry Pi ECU via a Bluetooth module. The Raspberry Pi houses an Android human-machine interface application that visually presents the battery status during smart charging. Supply equipment component. Within the SE, we have the supply equipment communication controller with the AUTOSAR V2G stack. This controller enables smart charging from the SE side. The SECC controls a relay that has a controlling signal from SE and a power supply as inputs and the electric vehicle charging signal as output. Additionally, a logic analyzer is employed to monitor the C, allowing us to observe when the SE supplies power to the EV and when it ceases to do so. V2G sniffer component. The V2G sniffer can be connected to either the SE or the EV. The Nucleo board acts as a sniffer, capturing the communication between the SE and the EV. The sniffed messages are then forwarded to a PC through an Ethernet connection. Subsequently, the V2G Shark software on the PC is capable of decoding the V2G messages, facilitating analysis and visualization of the captured data. Here we have 2 videos available that showcase the first 2 demos of our project. The first video shows smart charging using V2G technology. The second video focuses on the V2G sniffer and its integration with V2G Shark for decoding a sample of the V2G messages. In our first video, the lower right section of the screen presents the output of the logic analyzer, which is connected to the relay that derives the electric vehicle charging signal. On the top right of the screen, we can see the dashboard that displays the status of the battery during the charging process. At the upper right section of the screen, the dashboard is displayed, exhibiting real-time updates and the status of the battery during the charging process. On the left-hand section of the screen, we can see the setup of our project, as previously mentioned. This represents the physical arrangement and components of our project. Now we can see that the electric vehicle charging signal is low, indicating the absence of power supplied to the electric vehicle. However, upon connecting our project, we can see that the V2G sniffer starts capturing messages, which are subsequently displayed on the V2G Shark. These messages are the V2G messages which are sent prior to supplying power, such as Neighbor Discovery Protocol messages, the TCP three-way handshake messages, the V2G session setup messages, and exchanging the services and the parameters required for charging messages and agreeing upon them. Following the negotiation and agreement on the charging parameters, the SE starts to charge the EV. As a result, the electric vehicle charging signal rises. And simultaneous charging activity can be observed on the electric vehicle dashboard. Once the battery is fully charged, the SE will stop charging the EV, and we will see that the electric vehicle charging signal drops again. Then the SE and the EV will end this session. In our next video, we will shift the focus to the V2G Shark screen, allowing for a clear view of the decoded V2G messages. In this video, we revisit the same scenario demonstrated in the previous video. The sequence begins with the initial two messages, encompassing the advertisement and solicitation messages, which are associated with the network layer, specifically the ICMP protocol. Following these, the subsequent three messages represent the three-way handshake, associated with the transport layer, specifically the TCP protocol. Transitioning to the application layer, the first message, referred to as the app handshake, is transmitted and successfully decoded using V2G Wireshark as shown. Subsequently, the application layer continues sending various messages, including authorization, charging parameter discovery, cable check, and current demand messages. This message makes the relay supply power to the electric vehicle, persisting until the battery reaches its maximum charge level. To end this session, a session stop message is transmitted, followed by the four-way handshake for connection termination, which are associated with the transport layer, specifically the TCP protocol. At the end of our video, we would like to express our sincere thanks to Mona Helmi as the owner of the project idea and our first supervisor for her great management, encouragement, responsibility, invaluable advice, and continuous guidance, and we would like to thank everyone who helped us in various ways to have a good experience and to finish our project.